Let's get right into it. If you were born any time before the year 2000, you are intimately familiar with a specific kind of audiovisual nightmare. I'm talking about the screen of an old, chunky cathode ray tube television when it's not tuned to a channel. That frantic, mesmerizing blizzard of black and white dots, paired with that sound, that deafening, static sound. We called it snow. It was the visual equivalent of white noise, something you saw when the VCR was eating your tape of The Lion King, or when the late-night broadcast signed off for the evening, leaving you alone with your thoughts in this electronic poltergeist. But what if I told you that what you were seeing wasn't just random garbage? What if I told you that a tiny but very real percentage of that snow, that chaotic mess on your screen, was actually a fossil? A relic from the most violent and powerful event in the history of everything? That you were, in a very real sense, staring at the leftover heat from the creation of the universe itself. Yeah, that weird static you used to stare at after cartoons, it's a cosmic artifact of unimaginable importance. And today we're going to peel back the layers of this accidental window into the dawn of time. So to understand the ghost hiding in your old TV, you first have to understand what a television is even trying to do. Think of that old TV set not as a screen, but as a professional eavesdropper. It has one job: listen for a very specific story being told on a very specific frequency. An antenna, whether it's the classic rabbit ears or a big dish on the roof, is basically an electronic net designed to catch invisible waves flying through the air. Radio waves, to be precise. When you tune to a channel, say Channel 5, you're telling your TV, hey, listen only for the story being told on the 76 to 82 megahertz frequency. If the signal is strong, the TV happily catches it, decodes it, and shows you a rerun of Friends. Simple. But what happens when there's no story? What happens when you tune to a dead channel? The TV doesn't just give up and go silent. Oh no, it panics. It thinks it's gone deaf. So it does the electronic equivalent of cranking a hearing aid all the way up to 11. The amplifier inside goes into overdrive, desperately straining to catch any whisper of a signal it can find. The problem is, when there's no broadcast, all that's left to hear is the background noise of the universe. It's like being in a soundproof room and turning a microphone's gain up so high you can hear the faint buzz of the building's electricity and the blood pumping in your own ears. Your TV takes all that random, ambient, electromagnetic radiation floating around you, cranks the volume, and throws it onto the screen as a chaotic pattern of dots. It's a picture of nothing. Or so we thought, because it turns out that nothing is incredibly loud. All right, so your TV is amplifying random noise. But where is this noise coming from? You might think it's just electronic junk from your own house. And you'd be partly right. Your microwave, your cell phone, the Wi-Fi router, the power lines humming outside your window, they all create a local soup of electromagnetic smog. But that's just the start. Some of that static is from much, much farther away. Every lightning strike on Earth, no matter where it happens, releases a massive burst of radio waves that can bounce off the atmosphere and travel thousands of miles. A thunderstorm over Indonesia can paint a few dots on a screen in Ohio. Then there's the sun. Our star isn't a gentle, quiet ball of light. It's a raging nuclear furnace, constantly screaming radiation across the entire electromagnetic spectrum. A good chunk of that solar noise hits Earth, and your TV's antenna is more than happy to pick it up. So we've got a local interference, terrestrial interference from lightning, and solar interference. For decades, physicists and astronomers knew about all this. They knew how to account for it, how to filter it out. But in the mid-1960s, a couple of guys stumbled upon something they couldn't explain, something that would change our understanding of everything. They found a noise that wasn't coming from the house or the city or from thunderstorms or even from the sun. It was a faint, persistent, uniform hiss. And the most unsettling part? It was coming from everywhere, all at once. No matter where they pointed their antenna, the hiss was there. It was as if the empty space between the stars itself was quietly humming a single monotonous note. In 1940, at Bell Labs in Holmdel, New Jersey, two radio astronomers named Arno Penzias and Robert Wilson were trying to use a magnificent piece of equipment called the Holmdel-Horn antenna. It looked like a giant gramophone horn tipped on its side and was one of the most sensitive radio receivers on the planet. Their plan was to map faint radio signals from the Milky Way. But from the moment they turned it on, their work is plagued by that same annoying hiss, a persistent, uniform noise that was getting in the way of their real research. Being diligent scientists, they did everything they could to eliminate it. They checked the electronics, they rewired the systems, they pointed the antenna directly at New York City to see if it was urban interference. But the noise was the same. They waited for different times of day, different seasons, thinking maybe it was solar or military in origin. Nothing worked. The hiss remained, a constant whisper from every direction. Then they found their culprit, or so they thought. Living inside the giant antenna horn were two pigeons who had made it their home. Penzias and Wilson theorized that the birds, along with what they politely referred to in their papers as a white dielectric material, that's Nobel Prize-winning language for pigeon poop, were generating excess thermal noise. It was a plausible, if slightly ridiculous, explanation. So they set about evicting their tenants. They climbed into the horn, scrubbed it clean, and then trapped the pigeons and released them 40 miles away. The very next day, the pigeons were back in the horn. In a moment of scientific frustration that I'm sure many of us can relate to, Penzias admitted they resorted to a more permanent solution to the pigeon problem. But after all that, after cleaning the horn to pristine condition and ensuring it was 100% bird-free, they turned it on. And the hiss was still there. It wasn't the city, it wasn't the sun, and it wasn't the pigeons. The noise was coming from space itself. Imagine the sheer frustration of Penzias and Wilson. They have this multi-million-dollar instrument, and it's being sabotaged by a ghost they can't exorcise. They'd done everything right, and yet their data was still junk. They had no idea what to do. But here's where the story gets truly incredible. Just 30 miles away at Princeton University, a team of physicists led by a man named Robert Dicke were working on a completely different problem. They weren't trying to get rid of a mysterious noise. They were actively trying to find one. Dicke and his team had been theorizing about the origins of the universe. They had predicted that if the universe started in an incredibly hot, dense state, a Big Bang, then the initial blinding flash of light from that event wouldn't just disappear. It would still be around. Over 13 billion years, as the universe expanded and cooled, that primordial light would have stretched out, its wavelength getting longer and longer until it was no longer visible light, but faint microwaves. They calculated that the universe should be filled with this afterglow, a relic thermal radiation with a temperature of just a few degrees above absolute zero. They were in the middle of building their own antenna to go look for it. Then a friend told Penzias he should call the group at Princeton, so he did. Penzias described his mysterious uniform signal that came from everywhere and corresponded to a temperature of about 3.5 Kelvin. There was a long pause on the other end of the line. Robert Dicke knew exactly what he was hearing about. The story goes that he hung up the phone, turned to his dejected colleagues and said, "Well, boys, we've been scooped." Penzias and Wilson, in their quest to get rid of some annoying bird-related static, had accidentally discovered the oldest light in the universe. They had found the fossilized echo of the Big Bang. So what is this cosmic microwave background really? Why is a faint hiss from space so important? Because it's not just noise, it's a photograph. It is the oldest photograph in existence. To understand how, you have to imagine the universe in its infancy. For the first 380,000 years after the Big Bang, which sounds like a long time but is just a blink in cosmic terms, the entire universe was a terrifyingly hot, dense, and opaque place. It was a roiling soup of fundamental particles, a plasma so thick and soupy that light itself couldn't escape. Think of it like trying to see through an impossibly thick fog. The fog itself is made of water droplets, and light just bounces off them, scattering in every direction. You're surrounded by light, but you can't actually see anything clearly. The early universe was like that, but instead of water droplets, it was a hunk of free-roaming electrons. Photons of light would be created, travel an inch, and immediately smack into an electron, getting absorbed and re-emitted in a random direction. The universe was glowing, but it was also opaque. Then at around the 380,000 year mark, the universe expanded and cooled down enough for a magical thing to happen. It became cool enough for the electrons to slow down and be captured by protons, forming the first stable atoms of hydrogen and helium. Suddenly, the fog cleared. With all the electrons now locked up inside atoms, the photons were free. For the first time, light could travel in a straight line without bumping into anything. In that instant, the entire universe became transparent, releasing a brilliant flash of light in every direction at once. The cosmic microwave background is that light. It's the flash from the moment the cosmic fog lifted. It is, quite literally, the universe's baby picture. Okay, fine. The universe had a baby picture taken 13.7 billion years ago. That's neat. But how does a brilliant flash of light from the dawn of time end up as that pathetic, snowy mess on your grandpa's old TV? The answer is the expansion of the universe itself. That original light was incredibly energetic and hot. But for the last 13.7 billion years, the very fabric of space has been stretching. And as it stretches the waves of light traveling through it. This is called cosmological redshift. It's like taking a drawing on a rubber sheet and then stretching the sheet. The drawing gets bigger and distorted. The same thing happened to the baby picture of the universe. The wavelength of that ancient light has been stretched and stretched and stretched for billions of years. What started as brilliant, high-energy light has been cooled and elongated all the way down the electromagnetic spectrum into very faint, very cold, low-energy microwaves. And so we finally get back to your television. That antenna, in its desperate attempt to find a signal, is sensitive enough to pick up these ancient, tired microwaves. The definitive calculation is this. Of all the random static on an analog TV tuned to a dead channel, approximately 1% of it is the cosmic microwave background. The other 99% is all that other junk, the local noise, the sun, the thunderstorms. But a full 1% of those dancing dots, 1% of that shh sound, is a direct signal from the birth of everything. You were watching the echo of creation, and you probably just changed the channel to find something better to watch. It's arguably the most profound accident in the history of consumer electronics. For a long time after its discovery, scientists thought the cosmic microwave background was perfectly uniform, a smooth, featureless glow from every direction. And that presented a huge problem. Because if the early universe was perfectly smooth, then it should have stayed perfectly smooth. An even distribution of matter and energy would just expand evenly. There would be no lumps, no dense spots for gravity to grab onto. And without lumps, you get no galaxies, no stars, no planets, and no count, weirdly specific YouTube channels. The fact that we exist at all proves the CMB couldn't be perfectly smooth. So we sent up better eyes to look. In 1989, NASA launched the COBE satellite. Then came WMAP in 2001, and the European Space Agency's Planck satellite in 2009. These were the most sensitive cameras ever built, designed to stare at this ancient light and find the tiniest, most imperceptible variations. And they found them. They produced stunning maps of the CMB that looked like abstract art, showing minuscule temperature fluctuations, hot spots and cold spots that differed by only 1 part in 100,000. These tiny imperfections, these almost non-existent lumps in the primordial soup, are the most important features in the entire cosmos. The slightly hotter, denser spots were the seeds of cosmic structure. They had just a little more matter, and therefore a little more gravity. Over hundreds of millions of years, that extra gravity pulled in more and more material, snowballing into the vast filaments and clusters of galaxies that make up our universe. Every star, every planet, every person, every single thing you've ever seen is a direct consequence of those tiny, random quantum fluctuations from the first fraction of a second of time, immortalized as barely visible blotches on the universe's baby picture. So if this beautiful, ancient, galaxy-seeding light is still washing over us every single second, why can't you see it on your brand new wall-sized 8K QLED smart TV? Why did this accidental telescope disappear? The answer is simple. Our televisions got too smart for their own good. As we've said, an old analog TV was a dumb amplifier. When it didn't find the signal it was looking for, It just amplified everything else. It was a brute force approach. A modern digital TV, however, is a sophisticated computer. It's not looking for a wave. It's looking for a specific coded data packet. It's looking for ones and zeros that tell it exactly what color every single pixel on the screen should be. When your digital TV can't find that data packet, it doesn't panic and amplify the background noise of the cosmos. It follows its programming. It recognizes there is no valid signal, and it executes a command to display a calm, clean, pre-programmed screen, usually a placid blue or black, often with a helpful little box that says, "No signal." We have engineered the ghost out of the machine. In our endless pursuit of perfect, high-definition clarity, we designed a system that is now specifically built to ignore the most profound signal in the universe. The cosmic static is still there, still bombarding your house, still whispering the story of creation. But your TV has been taught to put in its digital earplugs and politely show you a blank screen instead. It's the ultimate technological upgrade. We finally filtered out the evidence of our own existence. So there you have it, more proof that the universe is far weirder and more connected than we think, and that sometimes the most profound discoveries are hiding in the most mundane places. If you want to find out what other secrets are lurking in plain sight, make sure you're subscribed for the next video.